Okay, so let's get started. Harry and his friends are using a slingshot to launch water balloons down the field. The water balloon is 3.2 feet off the ground when it is launched at a 29-degree angle. Its initial velocity is 78 feet per second. So we use the equation, the velocity, which is 78, times t, times the cosine of our angle, or 29. Then we have our second equation, which is negative 1/2 of our velocity, or 34, no, not 34, 39. So negative 39 t squared plus velocity, which is 78 t. And oh, I forgot gravity. So gravity will be, so it's negative 1/2 of gravity. So it's negative 32. Incorrect. It's negative 16 t squared. So the equation is negative 1/2 g to the 3 squared plus velocity times t times the sine of our theta. So then sine of our theta is sine of 29 plus our initial height, which is 3.2. So these are our two equations. Now, we're going to graph these two equations, or this parametric equation, into decimals. To do that, first we treat it as a coordinate point. So we first open our parentheses, then we write 78, and then we do t, then we close our parentheses, then we do cosine. So we go to functions, cosine of 29, then we add this, then we add another, and then we add a comma because we're now writing our second point, or our second equals negative 16 t squared plus 78 t. And we have to also make sure that this is in degrees, which it is. I already checked that. So, and then we have to go 16t squared plus 78t. We have 78t times the sine of 29, close parentheses, and then plus 3.2. 3.2 parentheses are closed, and that is our equation. Now we see that this graph doesn't actually cross our x-axis, so we make t go time, let's do 2 seconds, and it still doesn't, so let's do 3 seconds, and it crosses. So now we know how our water balloon is gonna go from this graph. Now let's figure out the time the balloon reaches its maximum height. So to do that, first we have to figure out what does it mean by height. So the height is just the y value. And to figure out the time, right there, we can just say y is equal to, so our second equation is basically us. So like it's gonna be our between 50 and 100, so like 75. But I'm gonna actually graph it right here and figure it out. So we are gonna graph this equation right here to figure out at what time does our balloon reach its maximum height. So let's graph that. Let's graph negative 16 x squared plus 78 x, then we have sine of 29, close parentheses, plus 3.2. So now when we click on this point right here, the height, or the y value, is our maximum height, which is 25.544, which makes sense because it's between 0 and 50. And the time it takes for the balloon to reach its maximum height is going to be 1.182 seconds. So do you have to round to anything? It doesn't say so, so we're just going to do 1.182 seconds. That's the time it takes for the balloon to reach its maximum height. Now, the time the balloon lands on the ground is going to be this point right there, because at 0, the time is 2 points. So we're just going to use the same equation and figure out when does it land on the ground. So let's see if it makes sense on our original graph. So on this graph, it should make sense. So let's see. So time the balloon lands on the ground, right? So, well, we can't actually see it, but the maximum height is 25.4, and at 0, it's 2 point, so it's more than 1.1 seconds. So I'm gonna say this is pretty accurate, and this is the answer. And the maximum height of the balloon, we also know that from this equation right here. We know that at 1.182 it reaches its maximum height, which is 25.544 feet. There we go. And then height of the balloon 1 second after Harry launches it. Harry and friends. Okay, so 1 second after. So 1 second after. So let's just, y is equal to, it's asking for the height, so it's asking for y is equal to -16 times 1 squared plus 78 times 1 times sine of 29 plus 3.2. So if we just graph that, let me just copy this. Can I copy it? Let's see. Let's see. There we go. Copy. There we go. Done. So we have that. And just replace every x with a 1 because it's 1 second after, and the x represents our time. So 1 parentheses, and then we put in a 1. There we go. That is the height. That is the height. 1 second after Harry and French launch it down the field. So the height will be 25 point, let's go to 3, or the thousandths place, feet. There we go. And does that make sense? Yes, because the maximum height is reached at 1.182 seconds. Then if it's 1 second after, and the maximum height was 25.54, it makes sense that the height at 1 second is less than 25.54. Okay, now distance down the field when the balloon lands. So the distance down the field when the balloon lands. How do you figure that out? So distance down the field, meaning we're now trying to figure out our x value. And when our balloon lands, we know that it lands at what time? 2.445. So we just plug in 78 times 2.445 times the cosine of 29 to figure out what our answer is. So 78 times, and our x is gonna be 2.445 times the cosine of 29. Not 9. 29. There we go. And our answer is distance on the field is gonna be 166.799 feet. Now let's see if it makes sense. 799 feet. So as we know, This is where it's going to land. And I would say that that's close to 166 because it's between 150 and 200, and it's closer to 150 to 166.799 seems pretty accurate. And now we're going to distance down the field when the balloon reaches its maximum height. So when does the balloon reach its maximum height? Time the balloon lands on the ground, time the balloon reaches the maximum height is 1.182 seconds. So we're just going to plug that in. X is equal to 78 times 1.182 times the cosine of 29, correct? Now, we're just going to use this equation and plug it in. 1.182. Because we're still trying to find the distance, so it's going to be at 80. 80.636 feet, approximately. So there we go. Does that make sense? Yeah, because the maximum height is between 50 and 100, and it's somewhere around there. So yeah, 80.36 seems pretty accurate. Distance on the field 1 second after Harry and his friends launch it. So 1 second after his friends launch it, the time, so height of the balloon 1 second after. So maximum height of the balloon. Okay. So to do this, first we'll have to figure out, so distance on the field 1 second after. Okay, we don't have to figure anything out because we already know the time, so we just plug in 1 into our equation. 78 times 1 times the cosine of 29. So we just, there we go. And that's our answer. 68.220 feet. And that's all. Thank you.